Unit 1, Part 5. So we've just abstracted the logical form of this argument, argument 2, to if P then Q, Q then P, right? The P and the Q here are sentential variables, right? Much like, so they're sentential variables which take as substitution instances particular sentences, okay? So you are familiar with the notion of variable from mathematics, right? Here is a x plus y equals y plus x, x and y, that's a algebraic law, right? Law of association. X and y are numerical variables, right? They're variables that take as values numbers, right? You can substitute the x for any number. The condition, and this holds for logic as well, the condition is that you have to substitute the same number here and there, right? Substitute x for the same number. You can substitute any number for the y, right? As long as you do the same number there and there, you will, right, the particular arithmetical truth that you get, 2 plus 3 equals 3 plus 2, for example, will hold, right? So this says this is a law. Whatever substitution instances you put in, whatever numbers you substitute for the x and y, you will get a true arithmetical equation. You will get an equation, right? But the point of my analogy now was to say that's a numerical variable, takes as substitution instances numbers. We've got variables, but our variables are sentential variables. They take as values, right, they're P and Q, so they're variables. Variables are not themselves true or false, right? P is not true or false. It's a variable, right? It's like it's a placeholder, as Frege, philosopher Frege, who kind of invented logic, this modern symbolic logic, he would call it a placeholder, right? It's like a blank. It tells you that something has to go there. A sentence has to go here. So it's a sentential variable, numerical variables take numbers as substitution instances. Sentential variables take sentences. Any sentence, anything capable of being true or false, that's a sentence, okay? And just as you had to put the same x in here and here, this is the logical form of this argument, right? And the P that goes here and here, that's identical, right? If you substitute the same sentence in for the P here and here, and the same sentence in for Q, a different sentence, or can be a different sentence, in for the Q here and here, you have another instance of this logical form. Remember, an argument form is valid if a particular argument, particular concrete argument with actual English sentences, a particular argument is valid if and only if its form is valid, and the form is valid if and only if it has no instances, no substitution instances with true premises and a false conclusion, right? Look especially at page 11. This paragraph on page 11, I won't read it now because I just said the important stuff, but the passages I read from page 9 and this passage here on page 11 with all the bold and italics are the most crucial passages in this opening unit. They're the ones that set the agenda for the first part of the course, right? An argument will said to be valid if and only if it's an instance of and valid argument form. You can read it for yourself, meditate on it. So this is the argument form, right? So where are we? This is a particular argument. All the sentences are true, the premises are true, and the conclusion is true in this particular argument. Do we say that about the argument form? No. There's no truth values to these sentences because these are consistent variables. I should say, I elaborated on that because Klenk herself does not speak very rigorously on page 10 when she writes, right up here at the top on page 10, she says, the pattern of both arguments in these examples she has is either P or Q, comma, not Q, comma, therefore P, right? So I said or was one of our logical words, not is one of our logical words, either or as well. So the pattern of the arguments is that where the lowercase letters P and Q stand for simple sentences, such as the cat has eaten the mouse and John is at home. That's not quite right. P and Q don't stand for simple sentences. P and Q are sentential variables, placeholders. Right? It's important because you're gonna learn in Unit 2 or 3 already you've got to be very clear in the difference between when you've got variables P and Q and capital letters like A or B, capital A, B, C, whatever, where those capital letters will stand for particular English sentences, right? So the translation, you'll be doing a bunch of translation in the first exam, right? Or symbolization. Sorry, symbolization is what I mean. You'll be symbolizing particular English sentences and particular English arguments. And you'll be doing so by like this. This is an example of the symbolization of premise 1. Dan is Australian, then if Dan is Australian, then Dan is male. What you do is identify the simple sentences. We'll learn this in Unit 2. Simple sentences are Dan is Australian and Dan is male. There's a specific criteria for identifying sentences as components of other sentences. Top Unit 2. But you'll recognize these as simple sentences. And then we've got the form as the if blank, then blank, or if P, then Q. That's the form, right? But and the hook is the symbol for if then. But here we've got A and M, where A is it symbolizes the particular sentence, Dan is Australian, right? And M symbolizes the particular sentence, Dan is male. Right? It's like a dictionary, just a shorthand, right? So A and M, capital A and M in our symbolization, stand for particular sentences. So those are, this is the crucial bit, those are capable of being true or false. Right? A, capital M, capital B, whatever it's going to be. Those particular sentences themselves are capable of being true or false. And as we'll learn, because they're capable of being true or false, any sentence that constructs more complex sentences through the use of our logical words, like or and, will also have a determinate truth value. But that's getting ahead of ourselves. But there's a big difference between things like A and M that has a truth, where A and M have truth values, and sentences constructed of them have truth values, versus P and Q do not have truth values because they're variables. Okay? So anyway, here's the form of this. If P, then Q, Q, therefore P. Right? That's the argument form of this. So we can now say, I'll say this in the section, then I'll come back to consider the form of 1 and compare it. But let's sum up where we've gotten to in the quest to explain why 1 is an invalid argument. Its premises are true, its conclusion is true. Why is this a bad argument? Well, because it is possible for the premises to be true and the conclusion false. It's not necessary for the premises to be true and the conclusion also to be true. What does that mean? We said we're going to understand that to mean this particular argument has an argument form, and this argument form has instances of it where the premises are true and the conclusion false, right? This particular argument, if P then Q, Q and Q, two premises, and therefore P, there are substitution instances of that argument form where the premises come out true and the conclusion comes out false, right? And those substitution instances, one such substitution instance is a counterexample, and if an argument form has a counterexample, then every argument of that form is invalid. Crucial to note, validity and invalidity, it's a yes or no. There is no, you are mistaken, you are confused. If you say, this argument is valid is valid here, but it has a form which has instances which are not valid, or this argument form has some instances which are valid and some instances which are not valid, wrong. Every particular argument that has a form that has counterexamples is itself invalid. All right, I'll elaborate in the next bit.